A torpedo ray can make a shock as strong as 200 volts. That is enough to stun a fish, stop a small animal from moving, and make a much larger predator think twice. The ray does not need sharp teeth. It does not need to chase prey across the ocean. It hides under sand, waits for a fish to come close, and sends a strong burst of electricity through the water. This is the torpedo ray. It is also called an electric ray. It has 2 living batteries inside its body. When prey comes near, the ray turns those batteries on. But here is one important truth. The ray works best when prey is very close or when the ray wraps its wide body around it. Seawater carries electricity, but the shock gets weaker with distance. The torpedo ray is not shooting lightning across the whole ocean. It is using a short, powerful electric attack at close range. So how does this fish make electricity? Why does the shock stop prey from moving? And how can a flat animal hiding in sand catch faster fish without touching them first? First, look at the torpedo ray. It is flat and round, like a thick pancake with a short tail. It can be brown, grey, or covered in dark marks. It lives near the seafloor, often on sand or mud. The second part is sensing prey. Like sharks and other rays, torpedo rays can feel tiny electric signals made by living animals. Every fish muscle makes a very weak electric signal when it moves. Even a small fish resting in the water makes a faint signal. The ray has tiny sensing pores on its head. These pores are filled with jelly. They help the ray notice the small electric signs of a nearby fish, even at night or under cloudy water. So the ray does not need perfect eyesight. It can feel that something alive is close. Then comes the attack. On each side of the ray's head are large organs shaped a little like kidneys. These are the electric organs. Inside each organ are many flat cells stacked in rows. Each cell makes a tiny amount of electricity. When the ray wants to shock, its brain sends a message to the electric organs. The cells fire together. Electricity moves through the ray's body and into the water around it. If a fish is close, the shock can reach it. The electricity can make the fish muscles twitch or stop working for a moment. The fish may become confused, stiff, or unable to swim away. Then the ray moves fast. It lifts from the sand and spreads its wide fins around the stunned fish. The fins wrap over the prey like a soft blanket. This keeps the fish close to the strongest part of the electric field. The ray may send more pulses. Then it guides the fish toward its mouth, which is on the bottom side of its body. The ray does not need a long chase, it needs one good surprise. This makes the torpedo ray a very good ambush hunter. A fast fish may think the seafloor is safe. It may not see the ray. It may not know it is swimming over a living battery. Then the ray senses the fish, rises, and sends out a burst. The fish loses the one thing it needs most: control of its muscles. For a few seconds, speed no longer matters. The torpedo ray uses electricity for defense too. A shark may try to bite it. A large fish may press down from above. The ray can send a shock into the attacker. A painful surprise may make the predator let go. This is why the torpedo ray can live without a hard shell or sharp venom spines. Its defense is hidden inside its body. From above, it looks like sand, but inside are 2 electric organs ready to fire. People should be careful around electric rays too. The ray does not hunt people, it does not chase swimmers. But if someone touches one, steps near one, or tries to pick it up, the ray may shock in defense. A strong shock can hurt, surprise, and make a person lose control in the water. The biggest danger is becoming scared or confused underwater. It is best to look, not touch, and give the ray space. The ray's power is not endless. Making electricity costs energy. After strong bursts, the electric organs need time to recharge. This is another reason the ray waits under sand instead of swimming around all day. A hunter that uses electricity cannot waste it. The ray waits for prey to come close. It uses its senses. Then it sends a short burst at the right moment. Electricity also helps the ray in dark water. At night, a fish may be hard to see, but its muscles still make tiny electric signals. The ray can sense those signals. It can hunt where eyes are not enough. Seawater carries electricity well. This helps the shock move from the ray to a nearby fish. But the water also spreads the electric power out. That is why distance matters. A prey fish far away is safe. A prey fish close to the ray is in danger. This is why the ray often wraps its fins around a fish. It makes the distance small. It keeps the prey in the strongest part of the field. The ray turns its whole flat body into a close-range trap. So can the torpedo ray kill prey without touching it. It can shock a fish through the water when the fish is very close. But it usually catches, covers, or holds the prey right after the shock. The electricity is not a long-distance weapon, it is a close, hidden attack. The ray does not need to touch first to send the shock, but it needs the prey close enough for the water between them to carry a strong burst. This is still amazing. A fish can be swimming free, feel no teeth, see no claws, and suddenly lose control because a flat shape below the sand turned on a living battery. On a quiet seafloor, a torpedo ray rests under a thin layer of sand. Its eyes watch from above. Its sensing paws feel a small fish swimming nearby. Inside its body, thousands of electric cells are ready. The fish comes closer. The ray rises. The water flashes with a burst no human eye can see. The fish stops. And the flat patch of sand becomes one of the strangest hunters in the ocean.